10.2 Finding arc measures. Essential question: how are circular arcs measured? Can you prove circles are similar? A central angle of a circle is an angle whose vertex is the center of the circle. So this is the vertex and it's the center of the circle, and that's why we call it a central angle. So this angle is 59 degrees, then this arc right here will be 59 degrees, and this is how we write it. Very much like an angle, angle AOB is equal to 59 degrees. We use this little measure item. You're going to have to do that same kind of thing with an arc. And that little M says you're about to give me a degree answer. Okay, the measure of minor arcs. So this is the arc that's inside. If you think of the angle, it's inside that angle, and that's going to be a minor arc. The rest of the circle, right here, and that's the leftover from 360, that is known as a major arc. And major arcs are usually bigger than 180, and semicircles are 180 degrees. All right, let's go ahead and let me do some problems and show you. We want to find the measure of each arc. So I got to put a little M for measure, RS. And we usually use 2 letters for a minor arc, and we can see that the measure of the arc is the same as the central angle, so that'll be 110 degrees. Now, major arcs or semicircles need 3 letters. I want to go to R, T, and then S. So just start wherever it starts here and ends up here. And so we know we want this portion of the circle. So we write M measure of arc R, T, S, and that's going to be a major arc, and that's the leftover from 360. So that'll be 250 degrees. Next one is RST, RST, and that's going to go from here to here, and you can see it's taking half the circle. We have to use 3 letters to show that, and that's going to be 180 degrees. Adjacent arcs are arcs that share exactly 1 point. And just like with the angle addition postulate, so if we had an angle situation like this, A, B, C, and O, we would say the measure of angle AOB plus the measure of angle BOC is equal to the measure of angle AOC. The same kind of thing is going to happen with arcs. We're going to have an arc addition postulate. So the big arc is equal to the sum of the 2 smaller arcs, as long as they share a point in common. All right, so let's go ahead and find the measures of these arcs using arc addition postulate. So we want to find the measure of arc GE, and GE is this. And I know that this portion of the arc is going to be 40 degrees, and this portion of the arc will be 80 degrees. So I'm going to add them together, and that'll be 120 degrees. I want to find the measure of arc GEF. GEF, so it's going all the way around here, GEF. I already know that this portion is 40 and 80, and this arc will be 110. So I'm just going to take all 3 of them and add them together, and so that's going to be equal to 230 degrees. 230 degrees. Now we want to find measure of arc GF. Since this amounts to 230 degrees, then the leftover right here is going to be 130 degrees to get the 360 out of that, and this answer will be 130 degrees. All right, let's do it again. Measure of arc AC, measure of arc from A to C. Now we can go from here, A to C, or from here. Now this is the major arc, so since they're only giving me 2 letters, my assumption is they want me to do the minor arc. And that minor arc means I'm going to take these 2 arcs, 108 degrees and 29 degrees, and add them up, and that should be 137 degrees. Now I want to figure out angle ACD. So ACD would start here, A, go to C, and then go to D. And you can see we're going to add 3 arcs together. It'll be the 29 plus the 108 plus the 83. And so altogether that'll be equal to 220 degrees. I think you probably have the right idea, so let's go and see what you can do. Take a minute to stop the screencast, identify whether the arc you're finding is a major arc, a minor arc, or a semicircle, and then find its measure. And here are the answers. All right, congruent circles are circles if and only if a rigid motion or a composition of rigid motions map one circle onto the other. That's the only way you can have congruent circles. Okay, and here's the proof. Congruent, if you have the radii congruent, then you have congruent circles. And that's because you can go through rigid motion maps to get this moved over to here, and then these will align themselves because the radii are the same. Now the converse is also true. If you have congruent circles, then you know you can, if they're congruent circles, then you know that the distance from the center of the circle to a point of the circle is the same. So you know the radii are congruent. Okay, congruent arcs. 2 arcs are congruent if and only if they have the same measure and they are from arcs of the same circle or congruent circles. So we know that this arc right here will be congruent to this arc. If the circles are congruent and the measures are congruent, then these arcs will be congruent, and also the converse. Before we go to the proof, let's go ahead and take a look at what I'm talking about here. I want you to notice that all of these arcs are 90 degrees, but the arcs are not congruent to each other. You can see if I were to take this arc and translate it, it would not match CD. There was no way, because CD is much longer than AB and has a different kind of curvature so that it won't match. So we need 2 requirements. We need to have congruent circles and congruent measurements. Here's the proof. If the angles are congruent, then the arcs are congruent. Okay, we're talking about being in the same circle. So here the angles are congruent, which makes the measures congruent. They will be congruent to each other, and because they're part of the same circle, they will match each other. Now if the arcs are congruent, remember they're coming from the same circle or congruent circles, then we know the measures of their angles, central angles, will be the same, and they'll be equal to each other right here. Okay, tell whether the red arcs are congruent, explain why or why not. Okay, let's take a look at the red arcs. 1, are they from congruent circles? And the answer is yes, they come from the same circle. 2, are the arc measures the same? And yes, they're both 80 degrees, so the answer is yes. So when you can say yes to congruent circles and to the arc measures the same, then you can say yes, the red arcs are congruent. Okay, let's go over here. Number 1, do we have congruent circles? And the answer is no. So there's no way we can pass any other test. We're just going to say no, the red arcs are not congruent. And visually you can see this is smaller, this is larger. Second one, do we have congruent circles? And the answer is yes. Here's a little congruent symbol to show that the radii are congruent. And 2, are the arc measures the same? Arc measures same, and the answer is yes. We have 90 degrees, 95 degrees, and 95 degrees. So the answer is yes. The red arcs, red arcs are congruent. Okay, your turn. Go ahead and stop the screencast and see what you can do. And here are the answers. Again, I run through my 2 tests to tell whether they're congruent or not. Okay, similar circles theorem. It says all circles are similar. The only way circles can be similar is if they go through a similarity transformation. And so here visually we show you how to do that. You're going to use a translation to get C to map onto D. And then you're going to have this concentric circle look. Now what we're going to do is we're going to figure out the scale factor between these two. And the scale factor is, remember, the scale factor is the new divided by the old. So the new was the S distance for the radius divided by the old R. So if we take this scale factor and times it to our old radius, we'll get a new radius. And then we go through a dilation to be able to get the small circle to map onto the big circle. What are similar arcs? We have congruent arcs. Now the question is, what are similar arcs? And similar arcs only have to have the same measure. Now let's go ahead and take a look at this. So we have to decide whether the red arcs are similar, and the answer is yes. And that's because the arcs have the same measure. This is just similar. Now, these arcs are similar. The answer is yes. All the requirement is that they have the same measure. So this arc will be 90 degrees in measure, 90 degrees. So yes, arcs have the same measure. Now these are not congruent, they are similar. Similar means that we're going to be able to go through a similarity transformation to get one arc to map onto the other. And yes, same reason. And that's the end of the screencast.